Welcome to part 6 of our Code Studio Game Lab tutorial. Last time in part 5 I left you with a challenge to take all of this code that we have within our draw loop that is showing us the score or how many coins we've collected and to get this out of the draw loop. Remember, since the draw loop is what really runs our game, we want to keep as little code as possible within the draw function just to make our game easy to understand what we're trying to do with it, how our game is actually running. So instead of having 4 pieces of code here, let's try to replace that with 1. Now the way we're going to do that is to make this into a new function. So I'm going to open our functions tab. Let me just scroll down to the bottom of our code. And I'm going to drag the define a function, which again basically creates a new function. What is this function going to do for us? Well, it's going to show the score. So we'll call it show score. Try to name your functions with verbs or actions because again, what they're doing is really an action. So it's a good way to just keep your names helpful for you again. Name your functions after the action that they're doing. Okay, so now very simply, all we need to do is drag all this code. So the easiest way to grab all these blocks again is to just do like a click and drag a box to select them all. I can drag them down now. Doop de doop de doop de doop. And let's stick them right here in show score. We're still getting a little warning though. It says show score is defined, but it's not called in your program, meaning we've created this function, but we don't actually use the function anywhere. So let's go back up to our draw loop where we took all this code from, and I'm going to replace it with the, here we go, let's call a function. Let's add it right here, and let's say show score. We're calling the name of that function we had before. Let's test it out. And yep, looks like it's running. Now I want you to watch something interesting. Watch closely as I move the player close to this coin. Pay attention to when we actually collect the coin. Alright, so did we actually touch it? We didn't. Let me do it again with this one. Watch closely. Watch when the coin actually disappears. We were still several pixels away from it. Now you might be saying, okay, that's not a big deal that it's doing that. I mean, we're getting close to it. Whatever. But I think the problem is going to be in what we're going to be doing next. When we actually get our UFOs moving around, let's say a player gets close to a UFO, like right there. Well, what we're seeing with how close we need to get to the coin to collect it, we can still be pretty far away from it. Being right here, we might actually be getting tagged up by the UFO and then getting a game over. Our player would probably be frustrated, you know, raging, smashing their keyboard, going, what? I missed it. I didn't hit it. And I don't want to be responsible for anybody breaking a keyboard after watching this and playing this game. So we're going to fix this problem right now. Let's go to our animation tab. We want to make sure our player sprite is selected. It's our first one, so it already is. Pretty simple how we're going to fix this. Let's go over to the right. Let's find this button that says crop the sprite. Now watch, if you look at our picture of our sprite here, you know, the gold is our actual sprite, and then you have all these pixels that are just basically blank. But the way that GameLab builds our collision shapes, our boxes to detect the collisions, it uses the entire sprite, which means it uses all these extra pixels. This is part of our collision shape, which is why if our coin was basically just right here, we'd still be touching it. And if a UFO is right here, that would count as a touch. So we want to get rid of all this empty space we're not using. So let's simply find this crop to sprite button and click that. And it auto-magically, I love that word, auto-magically cuts out all this empty space and shrinks our sprite down to just the part we need. Okay, so let's now go back into the game. Let's run it again, and let's see if this is any better. So as we come up... Oh yeah, that's a lot better. We had to actually get right up to it and touch it. And... boop. And... boop. Cool. Now you notice I made a mistake. If you remember in the last video, I said let's try to make sure our scoreboard or our coin count shows up above our player. I forgot to do that here. So our shows, when we call our show score function, that should actually come after our draw sprites. So let me see if I fix that. And yep, there we go. All right, let us now remix. And we're going to rename this Dodge Game Part 6 and save it. All right, let's take a pause from our actual coding and talk a little bit about game design. There's really two major components you have to think about when you're designing your game in terms of how is the game going to play. And the first thing you need to think about is, what is your game's objective? In other words, what is the player trying to do in order to win the game? Now, in our case, there might not actually be a specific win condition where you do something that makes a message on the screen come up and say, "You win! Yay, you're the best!" But, you know, we still have an objective, and our objective in this game is that we're trying to collect coins. Now, it could be, you know, there's a lot of games out there where you never actually win, but it's all about just trying to get the highest score possible. And that's kind of how this game is shaping up to be right now. So we have our objective working. We're collecting our coins. But now the thing we have to think about, in order for this to be a fun game, is what is our challenge? If you think about games in general, games are one of the few things in life that we actually want to be hard. If a game was not challenging, we'd be bored. There'd be no point in playing it. And the way our game is right now, moving around and collecting these coins with no risk of failure in the game it's going to get boring in about 15 seconds to a player. So we need to make sure we can add that challenge now, and we're going to do that by making it so those UFOs that we don't want to touch are going to be moving around the screen. There's really three ways we can do this or take care of our enemy movement. We can have a constant movement, meaning we can make that UFO be moving in a constant way, very predictably all the time, probably moving back and forth across the screen. Another thing we can do is program in some random movement on this. I like to think on my TV, there's like a screensaver. If you pause your show for too long, it shows a little DirecTV logo just kind of like bouncing around the screen. It's somewhat random. That would kind of be what this would be like, where your enemy sprites are just sort of moving. You don't know where they're going to go after they hit the side of the screen. They're just kind of moving around. And the third way we could handle this is by having intelligent enemy movement, meaning that our UFOs would actually be changing their direction constantly, trying to move intelligently and actually catch us. We're going to implement our constant motion on one of our UFOs, so I can show you how that works. And then we're actually going to implement a very basic artificial intelligence on our second enemy sprite. So let's get into it. Now, the first thing we're going to want to do is think about how fast we want our UFOs moving. Remember, with our player, we made this player speed variable, and we set it to a value of 3. We're going to make something very similar for our UFOs. So let's go to our sprites. And we're actually going to not want to do sprites. I'm sorry. We're going to want to go to our variables, and we're going to be declaring a new variable. So let's grab this, and let's drag it right under our UFO1, because this is going to apply to UFO1. Okay, so let's call this UFO speed. And what value should we set it to? Let's try going with the same speed as our player, right? Value of 3. I'm gonna say maybe let's start a little bit lower. That might be too much. Let's go with 2 for this. So we have a little bit of an advantage in that we can move faster than the UFOs. We may tweak this later, who knows, but let's just start with 2. All right. So now let's start with this UFO, UFO1, the one that spawns up in the top right. What I'm thinking we do with this one is we make it so that it basically moves at a diagonal, and it'll start moving up away from the player, give us a few seconds to sort of plan where we want to go to get out of its way. Once it hits the corner, it's going to bounce back, come this way to the bottom left corner, and then bounce back to the top right. So it's going to be a constant, predictable motion going back and forth between there. So let's start by setting how is it going to move from the start. Now again, whenever we want to set a condition that we want to happen from the start, and we're going to want this variable to last through the entire program. It may change, but it's still going to last through the entire program. We want to add it in these initial variables that we set up that start at the very beginning of when the game starts. So we're going to be playing with the sprite's velocity, like we did with the player. So let me grab our velocity x, and we'll drag it under UFO1, and let's drag velocity y. So we're going to be changing both the x velocity and the y velocity. So think about this. If we give a positive value for both x and y, that means our sprite is going to be moving positively in the x and then positively in the y. So that means, again, if you're going positive and positive, we're going to be basically going diagonal down to the right. And I want to go diagonal up to the right. So the way we're going to do that is make it so we're starting with our x value being positive and our y value being negative. So let's just take our x, and we're going to set this to UFO speed. Now our y, we want to basically be negative UFO speed. So let's grab a math block. We're going to take multiply. And like we did before, with the moving the player, we're going to do a -1 times UFO speed. All right, let's test. Oh, what is it? Oh, yep. Again, gotta remember to name these. Which sprite is it affecting? And it's our UFO1 variable. So UFO1 and UFO1. Okay, warnings went away. I think we're good. Let's reset. Now pay attention to where this UFO moves and how it moves. All right. It moved in that direction and it went clear off the screen, so that's cool. That's very cool. That worked. Okay, but what do we want it to do when it hits the edge of the screen? Now we could potentially have it do what we did with the player, where if it hits the edge sprites, it changes direction. I'm going to show you a different way we can control this, which is going to be, we're going to just focus on the y values, not necessarily the velocity, but the position on the y-axis. If our sprite gets up to the edge, let's move it down. Let's turn it around. Let's have it start going down. And then if it gets all the way to the bottom y value, same thing. Let's stop it, turn it around, have it go back up. We're also going to have to flip our x velocity to make it go back and forth left to right. So this probably sounds very confusing. I don't think I'm explaining it too well, but let's see how we do this. So we want to start by making a new function. Let's drag this down to the bottom. Let's call this move UFO1, because its job is going to be to move UFO1. So again, think about the way I said how this is going to work. Listen to my words carefully. If our y value is, let's say, less than 5. Again, if our y value is less than 5. So can you guess what block we're going to want to start with here? The one that says if. We got to start with our if statement. So if our sprites, here we go, our position, our y coordinate, if UFO1, if it's, I'm forgetting a block here. Get rid of that for a second. We want to check if it is less than or equal to a certain value. Maybe we'll say like 10 for now. So we actually need to go to our math and get a math block. We want to take this one. This is less than or equal. So let's take less than or equal and put that in here. Now we can fill this in. So if UFO1, I'm doing the wrong thing again. Now is where I want this y position variable. Oh yeah, so many variables. If UFO1.y, the y position, is less than or equal to 10, well, what do we want to do? We want to set its velocity.y to now be going positive, getting the y's bigger, going down the screen. So let's drag that in here. Let's say UFO1.velocity.y equals, and if it's going to be getting positive, we can just use the variable UFO speed and enter that. Now we also need to adjust the x velocities. So let me grab our sprite velocity x. Again, we're going to assign this to our variable UFO1. Now here's where we're going to need an extra math block, because once we hit this corner, we're going to be going back like this, and as you see, our x values are getting smaller. So we need to be going in a negative UFO speed. So let me take our trusty multiplier. I'll do -1 times UFO speed. Okay, can't run it yet because, again, we defined it, but we never called it in the program. So let's go to our draw loop. And why don't we, I think a logical place to put this would be right after we move our player. Let's first move our player in the loop, and then we'll move all of our enemies. So this was called move UFO1. Warnings went away. Let's test it. UFO goes up, and UFO turns around. Cool, that works. Runs us right over. That's okay for now. And goes off the screen. So now we need to make it bounce back up this way. The way we're going to do that is we want to basically reset the variables for the velocity to be this. Velocity x equal to UFO speed, velocity y equal to -1 UFO speed. So I'm going to be lazy for a moment, I think, and I'm going to go to show text. We're going to just copy and paste some code. Let's go all the way down to the bottom. And I want to basically copy my if statement here. Remember, we need to grab curly brackets here, always go in pairs. And at the end of an if statement, or within the if block, there really is one set of curly brackets. So make sure I click after that, highlight everything including my if statement, Control-C to copy, and go to a new line all the way against the edge, and Control-V to paste. I'm still going to be checking if UFO1's .y, its y position, I'm still checking that, but instead of seeing if it's less than or equal to 10, I want to see if it's now greater than or equal to 390. So let's just change this from less than or equal to greater than or equal. Again, notice this is different from how you would normally in a math class handwrite less than or equal or greater than or equal. We don't have that easy sign with, you know, the one bar underneath the greater than. So we just combine the greater than symbol with the equal sign. So we want to check if that is greater than 390. Now, if it is, we just basically need to flip what we already had again. So simply, I'm just going to take where we said velocity.y and change that to velocity.x and change x to y. And I think that should do the trick for us. Let's test it out. Goes up, turns around, goes down, and it turns around. Cool. All right. In watching this, I think that UFO was going pretty slowly, so I can already tell I'm going to want it to go faster. I want a little bit more of a challenge in the game. So I'm going to change the UFO speed from 2 to 3, and let's run it. Yeah, I think now I got to be thinking a little faster to make sure that I stay out of its way, so that'll be better. All right. Video's going kind of long, but before we leave you, I want to get UFO 2 moving. Now, this will be a little bit more complicated how we're going to do this, but we're gonna set some new variables that are built into our sprites. So we're going to make some changes to how this sprite is going to operate. First thing we're going to do, let's go to sprites, and we're looking for a function or a property. But basically, this is a variable built into a sprite variable. It's like a variable within a variable, sometimes called a property. And we want rotate to direction. We're going to drag this in here. And again, I want to change the name to UFO2. All right, this is interesting. I want to pull up the example because we use a different kind of value for this. So look at the example of how this is used. Right here on line 6, it says sprite.rotate to direction equals true. This kind of variable is called a Boolean. And a Boolean either has to be equal to true or false. And I'll explain more about Booleans in the next video because we're going to use them more. But basically what we want to do for this rotate to direction property on the sprite to actually be working, we want to set it to true. Now basically what this is going to do is lock the rotation property of the sprite to the sprite's movement direction and vice versa. That's not exactly worded very clearly, so let me explain it better. Oh, it looks like you left one of the oh yeah, I have to actually enter this. I don't know why it gives me the error right there when my problem was right here. Anyway, alright, equal to true. Okay. So basically what this is going to do with our UFO2, if you imagine the pixels on this very edge of it, we're basically going to be always moving the UFO in the direction these pixels are facing. Now with our player, you know, if I want to go up, down, left, or right, our sprite is still facing the same way. We're not actually rotating our sprite. We're not turning its head or anything. But when we move this, we're always going to basically be moving it in this direction. Think of it like a car. And if we want to be going up the screen instead of just straight moving up, we're going to have to curve and turn it. So this is going to twist and rotate. So it's still always going to be moving towards whatever pixels are right here, but we're going to turn the whole thing. And basically, we're going to try to make this always facing and moving towards our player. So, it's getting annoying for me. Alright, we set this to true, and now we have to add one more property to this. And we need to add it's a built-in function that's called set speed and direction. I'm going to drag this right under here. So we're going to call this UFO2. We're going to set speed and direction. The way this function works is first we need to enter the speed that we're going to be traveling, and then the direction we want to be going. Okay, so the speed, that's the first value within our parentheses, or the parameter as we call it, the first parameter. So we want the speed to be the same thing as UFO speed. That's why we made that variable. Now the direction, these are in degrees, and we actually, it starts, normally we would think of 0 degrees being like straight up, but it actually uses it this way. So now let's see what happens if we run this and see how we start going that way. Okay, so far so good. We're almost there. Now we just need a little bit more code to actually make the UFO turn and follow us. So we're going to go down to the bottom and we're going to make a new function, drag in a new declare function. Let's call this move UFO2 because it's moving UFO2. And we're going to be adding one function within here. It's going to be, yeah, we're putting a function inside a function. It's a function that already exists. Back under our sprites tab, we're going to be looking for the function that's called point2. Here we go, point to an x and a y. So basically it's going to want to point to a certain position with an x coordinate and a y coordinate. So let me drag that in here. Let's change the variable name that it applies to be UFO2. So how do we decide where to point it? What would be the right numbers to put here? So watch what happens if I do point to 200 by 200. And I'm just going to get the player sprite out of the way, but we'll just follow UFO2 and see what happens. Oh, nothing right now. Why is nothing happening? It's defined, but oh, it's not called in the function or in the draw function. Okay. So let's go to our functions tab, call the function, and we're going to put it right after move UFO1, move UFO2. Okay. So now again, watch UFO2 and see what it does. It moves straight towards, not me, but it moves straight towards the center, right there. Yeah, it's bouncing around. Don't worry too much about that for now. But the point is it moved to whatever point we had here. So what do we do if we want it to be chasing us, always moving towards the player? Think about that for a second. Pause the video if you want a challenge to think about it. How do we make it so it's going to always go towards us? Alright, well the way we're going to make it always go towards us is instead of setting a specific constant point here, let's just change this to be equal to our player's x coordinate and our player's y coordinate. So again, what I did is I went back to the sprites drawer. I grabbed the property, or the variable within a variable, for the x and y coordinates and dragged those in. And I set it to look for the player's x position and the player's y position. So now let's see what happens. Notice as I move and turn, the UFO is trying to move and turn and follow me. So hey, that's working really well. I'm having a hard time keeping away from it though. It is just chasing me like crazy. So I think we might need to change the speed for this. I like this UFO moving a little bit faster because we know exactly where it's going to go. But this one being so fast, I think makes it a little bit too challenging. So let's make one more variable. Well, not variable, but we're gonna be setting the speed for UFO 2. Let's go back up here to where it says set speed and direction. We had it set to UFO speed, and now I'm gonna delete this. Let's take a math block, and I'm gonna put in the multiply. We're gonna take our UFO speed, and we're gonna multiply it by some value, something. If we multiply it by 1, that means it would be the same speed. If we multiply it by 2, that means that it would actually be going twice as fast, what we don't want. If we multiplied it by 0.5, it would go half the speed. That might be too slow. So your challenge, very simply today, I didn't even make a challenge slide for it because this is too simple. I want you to play with these values. I want you to play with different numbers. Do some game testing here. Decide what you think is a good value that balances the amount of challenge this is going to be. So again, I'll give you a hint. Pick something between 0.5 and 1 that you think works well. Until next time, I'll see you later.